Good morning, friends. It's Dr. V. M. Tidke from Sanjeevani College of Engineering, Department of MBA, Kopergaon. Let us continue our studies of Decision Science, Unit number 1, that is Linear Programming Problem. Friends, after studying the LPP model formulations, now let us move for the graphical solution to LPP problems. So, at the end of the session, every student will be able to understand the graphical solution to LPP problem. Friends, till the time we have just tried out to develop the LPP models based on the objective functions which are subject to certain constraints and on the assumption of non-negativity. Now, moving further, we have to find out the ways by which we can exactly identify the values involved, that is, going for the solution. Now, for understanding the graphical solution, we should know some terminologies. One of them is a basic feasible solution. A basic feasible solution is termed as a solution which satisfies the non-negativity condition as well as the constraints. Okay, friends, a basic feasible solution can be many. So for a simple problem, there could be many basic feasible solutions. I will help you out in explaining it with some different aspects. Say for example, what is the multiplication of two numbers? Which are the numbers whose multiplication would come to 12? So I have many choices. Choice number 1 is 6 into 2 is 12. 12 into 1 is also 12. 2 into 6 is also 12. 3 into 4 is also 12. And 4 into 3 is also 12. So, to have a multiplication answer to be 12, you have many choices. 12 into 1, 3 into 4, 4 into 3, 6 into 2, 2 into 6, or many like this. So all these possible choices are in our context are nothing but the basic feasible solutions. So I hope you'll understand the concept. A basic feasible solution is nothing but a solution which satisfies both a non-negativity condition and a constraint condition. Okay, so in a problem there could be many feasible solutions. Now friends, in these many feasible solutions there lies one important aspect which is of our interest, and that is a optimal feasible solution. So what is optimal feasible solution? A optimal feasible solution is a basic feasible solution which optimizes the objective function. मतलब ये ऑप्टिमल फिजिबल सोल्यूशन वो होता है जो कि इन बेसिक फिजिबल सोल्यूशन में से ही एक है, पर उस सोल्यूशन के ऊपर हमारा जो ऑब्जेक्टिव होता है, ऑब्जेक्टिव फंक्शन होता है, वो ऑप्टिमाइज हो जाता है. ऑप्टिमाइज माने either gets maximized if it is a case of profit or gets minimized if it is a case of cost. तो एक ऑप्टिमल फिजिबल सोल्यूशन वो है जहां पे कि हमारा ऑब्जेक्टिव फंक्शन ऑप्टिमाइज हो जाता है. If it is a case of profitability, our profitability would get maximized at that feasible solution, or if it is a cost, then our objective function would get minimized at that feasible solution. Okay, so now let us try to understand how to develop the graphical method of solution. Friends, the various steps involved in the graphical solution of LPP model is: number 1, you have to formulate the problem as a LPP model, something which we have already learned. So the step 1 is you have to formulate the LPP. Second, you have to plot the constraint lines on the graph. With the help of graph paper, you have to draw the lines of graph pertaining to the constraint equations and the objective function which is given to you. For plotting those lines, there are few things to be known. What are the things to be known as? Number 1, while plotting the constraint line, a constant on right hand side of equation must be positive. Say for example, there is an equation, linear programming equation is 2x plus 3y is equal to minus 4. So what is the note? On the right hand side, that is the constant which is minus 4 cannot be minus 4, it has to be plus 4. So to make this 2 plus 4, what you will be doing? You will be changing the equations, changing the signs of all the equations. The previous equation was 2x plus 3y is equal to minus 4. Now the changed equation would become minus 2x minus 3y is equal to 4. What you did is you have made the right hand side constant to be positive, and for doing the same you have shifted the signs of all those which are there on the left hand side of the equation. So the first condition, all the constants on right hand side has to compulsorily be positive. If not, we have to make them positive by changing the signs of the entire equation. Number 2, replace the inequality sign by equality sign. Friends, as we all know, there are three kind of possibilities in the constraint equations. What are they? Either you would have a equal to, or greater than, or less than, or a combination of this, that is greater than or equal to, or less than or equal to. So if in an equation there is an inequality sign, that is greater than sign or less than sign or greater than or equal to sign or less than or equal to sign, then you have to compulsorily replace that by equal to sign. How to do it? Take the same equation. If there is an equation called 2x plus 3y is greater than 4. So for plotting a graphical solution, we have to change this equation like 2x plus 3y is equal to 4. Okay, so you have to replace the inequality sign by equality sign. Fine. Next, step number 3 is identify the 2 points on the line to draw the same. Friends, as we are already knowing, to draw a line on a planet on a xy plane, you compulsorily requires 2 points, and if you get 2 points, you can join those 2 points and there finds a line which you are aiming at. So when you are going for a graphical solution, you have to identify the 2 points on the line. How to do that? It's very simple. If there is an equation with the two variables, that is x and y, firstly in the equation you have to put the value of x to be 0, then you will get another coordinates of y, then put the value of y to be 0 and you will get the coordinates of x. Say for example, in our case there is an equation 2x plus 3y is equal to 4. What we will be doing in this case? We will put the value of x to be 0. So 2x plus 3y is equal to 4 would be giving you the values of coordinates y. Identify those points on a xy plane that we are knowing. Then what you do is you will be putting the value of y to be 0. The equation was 2x plus 3y is equal to 4. So put the value of y to be 0. You will get the coordinates of x, and also put that point on a graph. Now you have got 2 points, point A and point B. And now after joining that 2 points, you will be getting a line which is nothing but a line of that first constraint equation, and subsequently you will be drawing the lines for further constraint equations. Okay, and then this is how your all the lines would get plotted on a graph paper. Now moving further, the third step in the development of graphical solution in LPP is you have to identify the feasible region or solution space. What is the feasible region or solution space? I will explain. As I said you, when you are drawing a graph, there are two axes. One is the x-axis, another one is a y-axis. As we are knowing, when we will be drawing certain lines onto that, we will be getting a certain area which is common to all. How to identify this common area of all the equations? I will help you out in understanding. So for example, your first equation was 2x plus 3y is greater than or equal to 0. Remember the sign greater than or equal to. If it is greater than or equal to, the area covered was away from 0. Okay, so it is opposite to the 0 and including the line itself because it is equal to also. Okay, now if there is an equation less than or equal to 0, say the same equation 2x plus 3y is less than or equal to 0. This region is nothing but the line itself along with the area which is close to 0 coordinate. Okay, then if there is an equation called 2x plus 3y is equal to 4, it is including only the points on that line. Okay, and if it is 2x plus 3y greater than 0, then all the area above that line without including the line itself. And if the equation is 2x plus 3y is less than 0, then it is the area below that line but which do not include the line itself. So this is how you will be getting the areas associated with all the constrained lines which you have drawn on a xy plane, and based on their areas which are in under the purview, you will be finding out the common area or a feasible area, and that area is nothing but a feasible region or a solution space. Okay, now the last step is to find the optimum solution. How to find the optimum solution? When you will be getting a common space or a solution space, the solution space is on the basis of certain bounded area or sometimes unbounded area as well. So if you have got certain area, you will be finding out certain points which will be representing that area. Then what you have to do is you have to put the values of those coordinates on the boundaries of that solution space onto the objective function. Say for example, there is one point called A having coordinates 3, 4. So if your objective function was 5x plus 5y is equal, that is objective function 5x plus 5y, then you will be putting the value of this coordinate A, that is 2, 3, on the equation 5x plus 5y. You will get one value of z. We will call it as a z1. If there is another point with the coordinates B, 3, 4, you will be putting those values in the equation 5x plus 5y and you will get another objective function, that is z2. And similarly for all the constraints on the points that are appearing on the feasible region or solution space, you will be finding out the z coordinates for the same. And if the problem is of maximization, the z1, z2, z3 subsequently, whichever number you have found out, the maximum of them is nothing but your optimum solution. And if the problem is of minimization of cost or minimization of resources or anything, then amongst all the z values that you have identified, the minimum value of that is nothing but your optimal solution. And the coordinates would be representing the values of x and y, which are nothing but the variables of your LPP model. So this is the way by which you can find out the graphical solution for LPP model. Friends, I hope you have understood the video. So just do a small exercise. List down the steps involved in graphical solution to LPP model formulation. Thanks for watching the video. If you have any doubts to be asked, you can contact me on below mentioned details. Thank you. Have a nice time.